Okay, I think we will go ahead and get started. I'm going to keep an eye on the wait room, as is my colleague Colleen. We're expecting quite a group today, nearly 80 of us, which is phenomenal. So we don't want anybody to lose out. I do have some quick introductory remarks as we begin. So officially, welcome to the November edition of Lunch Bunch. For those of you that don't know me, my name is Ruth Jones, as you can see there on your screen. I'm with the Mines Foundation, and we are really excited to have such a big group, not just from the Golden area and in Colorado, but folks from Texas. We've got some out of international folks as well. So thank you for taking the time to log on. We are really excited this month to put the spotlight on our petroleum engineering faculty as we start to address questions and concerns about the future of the energy industry. It's a huge topic, of course, but we're going to take a stab at unpacking that a little bit, aren't we? Okay. With us today is the head of the Petroleum Department, Dr. Jennifer Miskimmons. And along with Dr. Will Fleckenstein and Dr. Jim Crompton, each of them will share their unique perspectives on this issue, what Mines is doing to educate our next generation of petroleum engineers, and how the current research and innovation that's happening will affect the industry as well. So again, all really big topics. And guess what? We have 1 hour. Okay, so we're going to do our best to tackle these issues. I may have mentioned this as we were chatting here a minute ago, but many of you submitted questions along with your RSVP to today's event, and I have shared all of those with our speakers, so we are all on the same page. But if those questions don't get addressed or we run out of time, know that we will do our best to follow up with you individually. And here in a minute, once we get started, I will post each of their email addresses in the chat. So if you want to reach out to them individually and continue your conversation after today, you are welcome to do that. And thank you all for being willing to field those questions. One more quick reminder that Lunch Bunch sessions every month are recorded. So if you have to punch out early today, or if you know somebody who wanted to come today but couldn't, or if you just want to listen to it all over again, we record these and save them on the Alumni Foundation website, which is weare.mines.edu. Click on Alumni, click on Events, and you'll find us. And at the bottom of the Lunch Bunch page specifically, you'll see a button that says View Previous Events. So they're all there for you to listen to and enjoy. And my goodness, I think I've spoken long enough. Let's get this party started. Dr. Miskimmons, I'm going to turn it over to you to get us rolling. And like I say, we'll keep an eye on the wait room and bring everybody in as we go. So thank you so much and welcome everybody.
Yeah, my pleasure. Thanks, Ruth. So yes, first of all, just, thank you for taking the time to spend some time with us today. The questions were definitely a little all-encompassing, but we'll see what we can do to at least give you an idea and a flavor of where we're going with things right now. So when we're looking at the future, we're trying to address a lot of different areas. So tried to my part of the presentation is very much going to be focused on kind of where we're standing right now, what our department looks like right now, and where we see maybe some of the short-term challenges and opportunities, and then also the long-term challenges and opportunities. And then I have two of my illustrious faculty with me today, as you noticed, that Will Fleckenstein and Jim Crompton, who are going to speak to you about a couple of the more unique research areas that we have going on right now that kind of give you a flavor of some of where we're going with things. So without further ado, figured it would be a good idea to start off with what our current vision is for the department. In association with the Mines at 150 initiatives, all departments on campus were asked to update or to put together what was called a Pathways to Distinction document as to what the future of that particular department is going to look like. And it's about a 4 or 5 page document. We're working on getting it on the Petroleum Engineering website, so you can take a look at that if you'd like in the future. But this is what our vision statement right now is our vision of distinction for our particular department is to lead the world in education, training, research, and innovation for the responsible and sustainable acquisition and development of subsurface energy resources. And I think this vision kind of leads into a little bit about what we're talking about today. We are a petroleum engineering department. We're going to maintain and be a petroleum engineering department, but there are a lot of ways that we can contribute to a lot of subsurface energy resources and things that are going into what people are referring to as the energy transition. So we wanted to make sure that we captured that when we went into our vision statement. So good idea and a good place to start is where are we currently as sitting as far as a department? And I'm sure given the audience today, you know the state of the industry and some of the big challenges that the industry is dealing with. So this particular slide is probably not going to be a huge surprise to anybody. What we are looking at right now is the U.S. undergrad petroleum engineering enrollment that all the U.S. department heads of the various petroleum engineering departments submit this to Lloyd Hines at Texas Tech. He's been tracking it for years for all of us. These are self-reporting numbers, so take them a little bit with a grain of salt. Some people include freshmen, some do not. They are only for undergraduate, but you can really see the spike in enrollment that was seen in that 2012 to 16 range, and obviously the big drop off that we've seen since then. The order of the schools in the legend are the order of current enrollment. And so Texas A&M has the highest, and you see us as that really solid black line just to highlight it. Right now, Colorado School of Mines, we have the 3rd largest undergrad bachelor's enrollment in petroleum engineering at this point in time. So where does that put us with enrollment? Well, you can see on this slide right now, we currently have 288 undergraduate students. This happens to be registration week, so we will, we're getting a feel for what our sophomore numbers look like right now as we speak. We have 72 graduate students at this point in time. About 2/3 of those are PhD, about 1/3 are masters. Something that's kind of exciting is that first bullet point. Some of you might realize this, some of you might not, but our department will be 100 years old in 2022. So we're kind of excited about that, plan on celebrating that a little bit. COVID-19 definitely has impacted the school. We could spend hours talking about the specifics on how it's impacted it. I just wanted to kind of mention a couple of things that specifically relate to our department. Really, because we are such a large international department, that's where we've seen our big impacts. Many students went home over the summer and are actually taking courses from home at this point in time. So even our courses that are being taught face-to-face, and we do have face-to-face courses right now at Mines being taught, many of those are, all of them are being remoted out so that students that are in different time zones or students that are not on campus can actually see those classes. And so we have roughly about 30 to 40% of our students that are taking classes remotely from someplace that's not Golden, Colorado right now. We are currently at 12.5 faculty. We don't cut them in half. We have a part-time faculty. In fact, he's here with us today. Jim Crompton is talking. But we're losing 2 faculty members to retirement soon. And so I just wanted to, since we have so many alumni on this call, I wanted to Bill Eustace will be retiring at the end of this year. And so Bill, many of you know, as our drilling faculty, has been around for 25 plus years. He's retiring on December 31st. And then George Sampaio, who happens to be our other drilling engineer, is going to be retiring next May. So we're losing kind of our entire drilling department at this point in time. We're running about 2 million in research. As you can imagine, with the industry right now, that is down a little bit. We have had some drop in industry direct support for research, which is pretty understandable. So what challenges are we looking at? I think this is very, very big picture. So stepping back a little bit from the department itself right now, we're looking at how we can address things that are going to be happening in the future. And so I've spent just personally a lot of time reading a lot of documents and listening to a lot of presentations over time about energy transition or transformation or the energy future, whichever you would like to think about it. A lot of people think that when we're looking at the energy transition that it's going to be some kind of magic switch that we're going to no longer use fossil fuels. There's just no physical way for that to happen. Doesn't matter who you listen to or who you talk to, there's no way for that to happen. The other thing that we're looking at is standard of living. Energy provides a standard of living improvement for it's a base foundation component. Energy is of people's standard of living. And this particular quote comes from the Oxford Institute for Energy Studies this summer, where that access to affordable, reliable energy is essential for the growth of strong economies, sustained improvements in the quality of life, and the eradication of poverty. And so when we look at energy and you look at this concept of where are we going with the energy, no matter really what study or report that you look at, fossil fuels are likely to drop in what percentage they are contributing. But no matter what study that you're looking at, there's still 50% of the energy mix in 2050. And likely beyond in that, again, depending on who you're talking to. A lot of that is natural gas. And a lot of that is potentially offset when you start to look at things like carbon capture and carbon neutral study opportunities. So we're seeing, big predicted increases in natural gas demand. We're seeing big increases in petrochemical growth areas. And especially as we come out of economic downturns, we're going to continue to see this. So this really speaks to the fact that petroleum engineering is definitely still going to be needed. There's another interesting statistic out there too. Rare earth minerals would need to see something like 300% growth to even make up part of the energy prediction that things like solar are supposed to take over in the next several years. So there's just, the numbers just don't add up to have some kind of switch where fossil fuels go away anytime soon. So how are we looking at that? How are we addressing that? And where are we going? Well, we're still going to educate, in my mind, and hopefully many of yours, the best petroleum engineers around. We are a petroleum engineering department. We will continue to teach the curriculum that we have taught for so long. But what we're looking at also is we know, based on talking to our industry partners, that we need to look at different ways to educate some of our students. So we're looking at how to diversify in both teaching and research areas. And so when we're looking at the teaching side of things, PEs will still need the basic skills. We're still going to need drilling. We're still going to need reservoir. We're still going to need production. But we're also looking at other skills. And one of those happens to be things like data analytics. We have added a minor in petroleum data analytics that many of our students are now starting to take. We are also developing fully online and accredited courses in both the graduate and undergraduate areas that can reach beyond Golden. I had somebody take a course this fall with me that was calling in from Abu Dhabi. And to combine some of those different areas, we launched this fall a fully online petroleum data analytics certificate program. The idea being that this can be not only for our students to take courses in, but if there are industry professionals out there that are interested in updating their skills, we have these certificates that are completely online and available to folks that are not with us on campus. And so we're looking at not only petroleum data analytics, but what other online offerings can we create, keeping the same level of Mines accreditation. And I've developed one of these courses, and I can tell you that our accreditation process on these online courses is pretty high, that we can reach further out to other people. Recruiting, broadening our appeal. We do see a lot of students coming in to Mines now that are kind of like, well, I'm not sure about petroleum. You know, there's political issues associated with that. Is there a future with that? So we're looking at how we can enhance our recruiting in those areas. We're actually going out to some high schools now in the region and working on those recruiting opportunities. And then from a teaching standpoint, we're also in cooperation with some other entities. We are working right now with Satbayev University in Almaty, Kazakhstan, on helping them with their teaching. And through that, we're seeing some recruitment to our graduate programs. When we look at the research aspects, when you look at our research portfolio right now, we still have very obviously strong areas in oil and natural gas exploration, production management. We've had for quite some time and still are seeing this. Unconventional reservoirs tends to be what I call a specialty in our particular department compared to other petroleum engineering schools. But we're also seeing some significant expansion into areas that complement what we do. Geothermal, I know somebody asked about geothermal in one of the questions they submitted. Yes, definitely. We're expanding into geothermal, and Will's going to talk a little bit about that. Space resources, carbon capture and underground sequestration, data analytics, health, safety, environment, sustainability, hydrates. These are all places that we have programs going on either now or have had in the recent past. And then we also see a lot of growth opportunities. Again, going back to, oil versus natural gas. Obviously, I have to remind a lot of people that natural gas is a hydrocarbon and it is a petroleum product, and that we do address this in our petroleum area. Carbon neutral efforts, CCUS, geothermal. We've also got some really good potential international programs going on right now. We have a research focused opportunity with Nazarbayev in Kazakhstan also, that we're working with a lot of faculty over in that area, and that's kind of a Mines-wide initiative. We're seeing a lot more interest right now from some national oil companies. And one of our biggest projects right now is actually with in our department is with a mining company. So we're looking at just some of that diversification across the board. So, one thing that we're trying to kind of get across, we can't fear the energy transition. It's not putting us out of business. It's something that we need to be part of the solution and convince people that we can be part of the solution and contribute to some of that. And along those lines, then we start to contribute to a lot of the Mines at 150 goals that play into that also. So I will be quiet for now, and I'm going to turn it over to Will, who's going to talk about some of these more specialized initiatives that we're looking at.
Right. Can we ask questions now?
Sure. Fire away.
Well, I just wonder, you talk about I think you said by 2050 that hydrocarbons would still be 50% of the energy. I wonder if that 50% in 2050 won't be just as many molecules as we are producing now with, say, 70%.
Yeah, no, I agree. And it really is, there's statistics, right, Dennis? it's how you look at those. Because even when I look at some of those, I think it's higher than 50%, just the way that we're looking at efficiencies and where some of these buckets get lumped together. So yeah, I do. I set it at 50% because that seems to be the lowest common denominator, but there's a lot of places that we're seeing even 60, 65%,
Well,
which is really close.
my point is that the whole thing is going to grow. I assume that
Yes.
the whole energy
Yeah.
amount is going to go. So 50% of that amount in 2050 might be just as much as whatever the percentage is now of a smaller number.
Yeah, it's a very good point. Yeah, it's an excellent point because we see population growth associated with all that too, right?
Yeah.
It's a good point.
And you know, Dennis, it is a good point, and I've got a slide that's going to talk a little bit about that as we start to look at these other energies. And so the first question, I just want to make sure people can see my screen up there and see a plug blaster tractor. Somebody's pushing that up a hill. It's so basically, my name is Will Fleckenstein. I graduated from the School of Mines and Petroleum in 1986, somewhat of a similar time of woes where the price of oil was dropping. Graduated in '88 with a master's degree, and had never heard of a horizontal well, and started drilling my first one, or planning to, in 1990. So the world changes. Today I want to talk about some of the technologies we're working on, one of which is disruptive technology for tractors and horizontal wells. You know, it's just when gravity isn't getting you anywhere. And so, let's see. So if one considers all of the energy that's being used in the world, three things become apparent. One is that all energy is increasing. Two is that renewables are increasing rapidly, but they're still a relatively small part of the energy equation. And three, that fossil fuels and hydrocarbons, oil, gas, and coal, are the predominant amounts of energy that we use. You can see again the increase in renewable energy, but you also see that big increase in fossil fuels. Nuclear power is once thought as a limitless and inexpensive power source, but experience really changes perspectives. And so we need new technologies for hydrocarbon usage and renewables, and to develop those, we really need to collaborate to move this forward. And so one of these opportunities we're going to talk about is geothermal power. And geothermal power is an energy source that provides power, you know, when the sun does not shine and the wind does not blow. So it's a baseline type of power. We've submitted two very large proposals for what is called Forge with the Department of Energy. We'll find out here in the next week or so if we get those multi-million-dollar types of projects. The point is, everywhere in the world, we sit upon a vast reactor, the Earth's core, and that radiates heat toward us, and we have to harness it. Now, geothermal power requires wells, it requires injection, everything needed for oil and gas, but you have to take the oil industry technology and convert it to geothermal uses. If you can develop what they call an enhanced geothermal system, which is the ultimate goal, which is basically using water flooding to harvest heat. And so what you're seeing here on the screen is where you've got horizontal wells that are drilled, and you're going to be injecting cool water in the injector. The water travels between these horizontal wells, and it harvests the heat and brings it out in order to power a power plant. Now, in order to be able to do that, you have to drill long horizontal wells and develop a subsurface heat exchanger, which does not exist yet. Further, we may be able to take natural gas and heat those produced waters further to feed a power plant, which means that this would be an area where natural gas could truly be a transition fuel. Now, the problem you have in horizontal wells in geothermal is that gravity is currently the only way to move in a well. And it's a doozy of a problem. the fact that if you think about it, gravity is acting on the pipe from the vertical section of the wellbore, or a compressive force from an injector on coil tubing or snubbing unit is essentially pushing the pipe into the well. So even in a horizontal lateral, that's all you have to move the pipe. And friction is relentlessly pushing back, bubbling the pipe. And so reducing friction will only get you so far. So here's an example of what we call the blaster tractor. And what you see is this electric wirelessly controlled battery operated tractor. We had some teams of students that are in the capstone course in mechanical, civil, and electrical engineering working on this to try and understand how to engage a wellbore and actually physically start to push and pull. And this is what we came up with. And this tractor is actually capable of movement at speeds greater than 100 feet per minute. Now, the key is these wheels that are right on the cylinders that are pushed out to engage the casing by internal pressure, similar to that to hold down buttons on packers or hydraulic underream or arm. The wheels follow an almost perfect helical path as the cylinder rotates. There's no individual drives, but they just move in response to rotation. It's very, very simple. There's three factors that control force and speed. It's the torque and rotation that's applied, the normal force on the wheels against the wellbore, and the traction of the wheels themselves. And that's it. It's that simple. Now, in order to make these prototypes, you have to have some students that are really bright and engaged, which this capstone course allows us to do. And then we're able to take these prototypes and start to show that we actually have proof of concept. And I think that's what actually got us to the point of the pre-approval process, where a lot of companies and schools that were applying for this Forge geothermal funding went away. So first you have to come up with the proof of concept, and I think that's a key thing. Now, if these tractors were the solution, they would be the solution. But instead, in coil tubing interventions, 70% of them use a friction-reducing device of some sort. And I'll skip on past this. Oops. And so basically, what we came up with was what we consider to be a real solution. And this is we call the blaster tractor. It's where you have these wheels that are engaging. They sit directly between the bit and a conventional mud motor. There's no transmission. It engages and it just starts to push and pull. And so this is going to be the heart of part of our proposal for this geothermal funding, is that ability to work in sort of these very large well bores where coil tubing can no longer work, because you're moving literally 100 to 200,000 barrels of water in order to make this subsurface system actually go ahead and work. And so there's a huge opportunity from a standpoint of a market, which is what we're trying to teach the students to be entrepreneurial. 3 to 5 years we'd like to do is to increase that penetration, start to develop these open hole tractors, and also to start to develop other types of tools, which is what you see in this animation, which is what we call the Frac Optimal type of a tool, which is another part of the system where you have a limitless number of sliding sleeves you can put in place. You have a ball that comes in and engages. You either push it through by hydraulic pressure from the surface, or it's going to land in the sleeve. So you just saw it blow on through. It goes to the sleeve it's actually going to land in. And what it'll allow you to do is then to use a lower pressure in order to actuate the sleeve and essentially lock it in place and frac against it. And this is a critical thing in horizontal geothermal, because again, that ability to go ahead and drill plugs out is a real problematic type of an issue. So you have to invent new tools, take things in the oil field, but to go ahead and make geothermal actually go ahead and work, as opposed to be the oddity that it is right now. And a real key to this is my teams. So we get these, best and brightest of our undergraduates that work on problems like this for a year, try and come up with a solution and then build it. and to see if we can attract some companies to help us. The tractors you saw, we'd attracted a service company to actually do the machining for us, to build those tractors, to see if we could actually build this. So they learned and we learned an awful lot about this. And so these are the development teams. These are the types of technologies we're going to develop in order to essentially be able to go to the next level of energy, whatever that transition is going to be. And thank you very much.
Jim, the floor is yours now.
It said you've disabled screen sharing, so you're shutting me out. Well, we're figuring that out. Let me introduce myself. First of all, to correct a mistake Ruth said, I'm not Dr. Crompton. I'm plain old Jim Crompton. But this year I was offered a position of professor of practice within the Petroleum Engineering Department. And I guess in substitute for not getting my PhD, my 37 years with Chevron was kind of a proxy or substitute with that. For those of you that may know me, I am a Mines alumni. I graduated in 1974 with a bachelor's degree in geophysics. And then I got my master's after that. So it took me something like 42 years to learn how to cross the street between the Green Center and Marquez Hall. But I made it there. The reason, I guess, why I was recruited was a major mistake I made. I went up to campus several years ago after I'd retired and moved from Texas to Colorado to an SBE Student Society event. The president of the society was a friend of mine from Chevron. And after the talk, I was cornered by Dr. Roberta Graves. And any of those that, you know, that when you're cornered by Dr. Graves, you're in big trouble. She approached me and said, Jim, we have this new undergraduate analytics minor that we are working on, and we need somebody to develop and teach the capstone course. And because my background in the quote unquote digital oil field had been going on for probably 15, 20 years before that, I guess I was qualified in her eyes. And if with that request, you can't say no to Roberta, so here I am 4 years later. I did put together with Dr. Eustace and the capstone course for the minor. And as Dr. Miskimmons was also saying that I have been helping to develop the two courses that are in our Petroleum Data Analytics Certificate Program, working with the Trefany Center on campus, which helps any professor, kind of take their course and help put it online. The specific little topic I wanted to go talk about here, hopefully you can see my slide now, is one that kind of no pun intended, but is a hot topic within the industry. And that's the problem of methane emissions. And and while Jennifer and also Will were talking about the importance of natural gas as a bridge fuel, maybe between coal and renewables over many decades, natural gas has a problem, and that problem is its emissions. And this is one that is growing and concerned by regulators, by the NGOs, the environmental activists are pointing to the fact that the process we use to particularly when gas is an associated component of a crude oil flow, is that we have trouble with leaks, we have trouble with emissions. Wherever you have a flare stack like is sitting on this particular case, that you are, getting rid of waste gas. And maybe this might be a safety issue. It might be an economic issue. I mean, the very low prices that the industry has been getting for natural gas has caused sometimes, the decision that said we're just not going to build the pipeline and take the natural gas to market because it's cost too much. And then there's issues just of operational efficiency and everything as we go through all the rest of that. So this is a challenge. Colorado is among the states that is debating these new and tougher regulations, but also New Mexico, also North Dakota. There are a number of states that are starting to take this, more seriously, and they're under a lot of political and economic pressure from a number of different parts of society about saying we need greener, more responsible gas. So what we've been doing here, and this is an interesting kind of relatively new research program that's sponsored by the Payne Institute of Public Policy on campus, again, is kind of a cross-departmental kind of effort where we're trying to bring Mines' expertise in production engineering, along with that of our applied math and statistical departments, and just the whole idea of air quality control. So what we're trying to do, and I guess this is, we have access to a relatively unique data set that was been donated to us by an environmental monitoring firm, and with the permission of two small oil and gas operators in Colorado. They're giving us a chance to look at the data that comes straight from the monitors around, that we can put around the oil and gas pad, if you will, maybe several wells, pad for onshore unconventional drilling and production. And we can be able to really take a look at the data. What is the data telling us? Today, and an awful lot of regulations are quote unquote self-reporting, where the operator will estimate how much emissions that are coming from their operations. But it's proving that, the traditional equations by which the operators use, which based on, how much oil and gas is being produced, what's the gas oil ratio, as well as these things called emission factors from different pieces of equipment that may have been established by equipment manufacturers. Are kind of released in this big EPA tome that people, pull the information from. But it's proving that those estimates are too low, and that the self-reporting process from the operators is reporting less than is actually happening. And now with the NGOs having access to methane sniffing sensors from satellites, and others, they're kind of calling the question on the industry is, are you being truthful in what you're trying to report? So our work is trying to really go from the ground data to use the data analytics tools that we have available, marry it up with the operational practices, i.e. through SCADA information or other operational reports. When is the well being under maintenance? When is the sensor being calibrated? When is the trucks coming up to the tank farm to take away the crude oil? And is the vapor recovery systems working? How efficient is the flare stacks? All of those interesting kind of questions. We're now trying to drive from data, not from biases, not from attitudes, not from kind of an attitude that the oil companies are doing something wrong, but let the data tell the story. And this would include better data that would go back to the operator so that they can operate, better, and then they can fix leaks quicker, and then that they can operate in different kinds of ways. But one of our challenges here is we don't have a sensor that's sitting right on the piece of equipment that's leaking. We may be just 100 feet away with a continuous monitor just off the location or just beyond the fence line, if you will. Or it could be from a drone flying above. It could be from a satellite that's 700 kilometers away. So all of these things, as we are essentially measuring a plume of gas in a larger volume of air. And then with that, we're trying to identify an event. We're trying to locate that event. We're trying to quantify that event in order, to help both the operator, the regulator, the community at large, et cetera, as we go through this. And it's an interesting challenge. It's not an easy one, but it involves many different departmental disciplines as we go through this. And we have to understand simple things like which way is the wind blowing? what is the heat and humidity? What time of day do you have with regard to some of these things? So it is a really fascinating multi-departmental sort of an approach. And so we've got several things that we've gone on trying to take a look at this. One of the examples that we've been able to, that we're studying right now, is an example of a bunch of thief hatches that were leaking on top of a tank farm. And there you can see our unit, our Project Canary is the emissions monitoring company that's donating the data to us. And from that, we can see just how close we are to that. And in this case, we have a known operational incident. We can be able to recognize exactly what that event looks like from the sensor data and the operational data. And then we can start bring in weather. We can kind of go back and say, well, could we see this beforehand? Can we identify what can we tell about it? And then how to display that information and communicate to others. It's a very interesting project, and we've got people from several departments. We've even at Dr. Fleckenstein's encouragement, I actually reached out to that same capstone senior design team. And we now have another one of these groups that actually is trying to build a mathematical model of an oil and gas facility and then turn it into a predictive simulation model. So we can kind of go from bottom up and top down to be able to get our hands around exactly how much are we emitting and what we can do to reduce that, to that sort of footprint, which is going to be necessary in a lot of different cases for the operators to continue to get permits to operate from their work. Now, just one little interesting of what some of this data looks like and what you might be able to do with this. This where we've got data from 4 different sensors around a production facility, and we can measure particulate matter, which obviously this summer we've been able to pick up some really interesting events which are related to all the smoke blowing through northeastern Colorado from all of the fires in the mountains, and even all the way from California. That's what our particulate matter sensors will tell us. But our total volatile organic compounds will also be able to go in there and recognize what an event looks like. And here's an example of a leak that happened over a period of about 30 minutes, but happened in these series of about 3 or 4 big spikes. And the spikes are easy to pick out because they're anywhere from 10 to maybe 50 times baseline as you go through this. So when you begin to look with the data, we can have data-driven understanding of what operational realities are really there. We can help the operator operate more cleanly, which then can improve their reputation, maybe even sell their natural gas at a premium to others who are not operating as responsibly. We can help the regulators with the verification of the data that they are submitted through self-reporting sort of processes. And we can help the community know just how safe their neighbors are as they go through this. So I'll turn it back to Jennifer.
Thank you. Thanks, Jim. So I guess now we're happy to answer any questions. We've been answering some, or trying to answer some in the chat as we go along. So I'm going to send off the last one that I was answering from on. So does anybody have any questions that we can address? There's several different topics, obviously, that we kind of went over, but
Jennifer?
yeah,
Jennifer, this is Carl Hines. It's more of a comment than a question. Let me put it that way. I was amazed about the 100 years of petroleum engineering. I want to assure you that I am 78 years of age, and only 18 of those were spent not associated with the Colorado School of Mines. So I have 60 of those 100 years. Okay, and if you do the arithmetic, that also you will find I graduated in 1964. And 64 was a very interesting year compared to where you are now and where you were in 86 with enrollment declining. And the year I graduated was the low point of petroleum engineers in the United States of America. We weren't replacing deaths in the industry at that point. Okay. So this is the perfect time, is what I will tell you. I had a good career because I hit the time just right on. Okay, luck is important. Serendipity is important. And that's one of the things mines ought to teach still. The second thing is that you got it all right, okay? You stick to the math, chemistry, physics, get people to think about things. The technology is important, and they got to renew their knowledge. Half of it every 7 years was the motto back then, but it's worse than that now. If they're not constantly learning, they're going to be behind and nothing flat. That's important because even though we think all the science is kind of dead and fixed and everything, it's not. I have spent the last 10 years understanding the line that exists between physics and chemistry. The chemists don't understand it, the physicists don't understand it, and it takes a good petroleum engineer to figure out methane is not a problem. It's called a building material for hydrocarbons, okay? And you can't do it the way we've been doing it. You got to do it with physics, and that's the trick. And it's things like that that will really kind of add up. Now, the other part you got trouble with, and I really think you have to address, and it's hard for you, is the greatest thing learned at mines is how to work with other people, professionals like yourself, and how to be part of an organization that accomplishes big things. And that's really, really important to have that practice. So you got to get them back on campus. You got to get them working together on projects like you are, but just overwhelm them with that kind of work. I mean, they need to do it under pressure and feel good. And you're looking at a guy who was at part of the crux of the development of Prudhoe Bay oil field from scratch, okay? And the building of the Trans-Alaska pipeline and pressing a green button that thing started. And those are things that I learned at the Colorado School of Mines. Lord love you, okay? And so tell the students right now, this is the moment to be in the petroleum engineering option. As that thing goes down and hits bottom, you want to be there, and you want to be able to raise your hand as a very well-educated petroleum engineer. So thank you.
No, appreciate that. That's a very good point. And I'm glad to hear you say that, because I actually met with a group of prospective students yesterday, some seniors, high school seniors, and obviously they had concerns about, future and whether they should go into it and stuff. And I kind of alluded to something very similar to that is, sometimes the downturns are actually the best time in the world to get into this. So no, I appreciate you saying that. Thank you. Yeah. Anybody else, questions or comments? I know we're kind of.
Well, the $1.8 million in research seems like a low number. Is that, how does that compare with what past years?
We're definitely down, Dennis. We're higher than we were last year, interestingly enough, but we're definitely down from the previous couple of years. Couple of things factor into that. One is just the downturn in the industry. We're definitely seeing some of our industry support, not renewed. We're a little bit more, the research dollars tend to be a little bit more delayed than even the enrollment numbers, as far as, because, people honor their commitments, but then they're not renewing some. So yeah, we're down in that. We'd like to be, our plans were probably at this point in time to be about 3 times what that number is. And so it's something that we're looking at. It's something we're trying to address. Some of it is, stepping, if we can't get industry funding, until things swing back up, where can we fill in some of these dollars with some of these more, shall we say, unique projects?
Well, it seems to me that the people that are putting that money in are getting a tremendous bargain, because they're getting all these graduate students working probably for nothing.
Yeah.
Right? Is that right?
That is correct. Yeah, and so I'll selfishly put a plug in that we're always looking to partner with companies and research projects and things, and grad students are not free, but they do tend to be a little bit cheaper than other lines of employment, and they are pretty doggone smart, right? So there's definitely ways that it doesn't have to be a big project. A small project that supports a student for a semester that's kind of a win-win for both sides is hugely beneficial to students right now.
Hey, Jennifer, it's Steve Enger.
Yeah.
Hey, any of us who run the numbers understand that natural gas needs to be a critical part of the energy mix going forward.
Yeah.
A lot of your students are getting input, because I'm listening to lots of stuff these days that says, I think as you put it, someone can just kind of snap their finger and we've transitioned energy, right? So how do you deal with that, I guess, is my broad question. And how do you, as you're trying to recruit students into petroleum engineering and they're being bombarded by mainstream media that says wind and solar is all we need, oil bad, and yet the numbers, because of the scale of this industry, don't support that can happen, anywhere near like the mainstream media would portray it.
Yeah. It's a great question. And a lot of it actually is kind of along the lines of what we just talked about. Some of the same slides that I just showed you, we're using in some of our recruiting now, is trying to get them to think about that, to get them to see that bigger picture. And the tagline I keep trying to get through to them is, if you're concerned about the problem, be part of the solution, right? So that's we're working hard on that. It's hard, right? Because you are combating that overwhelming message that they get. You're trying to get it through to them in a 30-second elevator speech, but we are seeing people. We're not we're not down to zero by any means, but it's something that has to become part of our recruiting. Absolutely.
And really good to see Harold Hines, my old boss's boss at ARCO. Looking good, man.
Same here.
I do see a question in the chat from Wade.
Yeah.
Jennifer, do you see that? And Will,
yeah.
Jim?
Yeah, Wade, I think, so your question, so for those of you that might not see it, global financial institutions have made the calculation from oil and gas investment isn't worth it in the face of societal pressure pushing against new oil and gas exploration. Are we concerned this could eventually have a trickle down effect and have impact institutions like ours? I think, we have to be at least aware of it. I think it goes a little bit back to Steve's comment that, the numbers just don't work out though. And so everybody, it's not an all or nothing. It's not 100% or 0%. Some banks are going to walk away from this. Some financial institutions are going to walk away for this, because they have certain reasons to do so. But I was listening to some presentations a couple of weeks ago of several large company CEOs. And one thing, even when you look at some of the companies that have said, okay, we're going to be carbon neutral, we're going to go greener and whatnot, it's not because they're getting rid of their fossil fuel portfolios. It's because they're changing the way they're approaching it for the carbon neutral components. And so am I concerned about it? Yeah, it's just part of that message that we just need to help try and make sure people understand the numbers a little bit better. So.
Hey, Jennifer, if I could pick in for a second.
Yeah, go ahead, Will.
I was just going to say, I went ahead and I'm getting ready to teach a lecture, and we're going over economics of unconventionals and conventionals and also alternatives. And one of the issues that really comes up is the laws of physics. I mean, you're going to start to find out where exactly you do have these problems, where these energy systems that rely on the sun to shine and the earth and the wind to blow, what happens when that doesn't happen, or at night. like in California, some of the really tremendous fires that they've had is trying to move the electrons from some of these alternative energy installations past where you have these grass fires that have turned into these horrendous fires. Just imagine if pipelines were doing that. So it's going to come down to the math and physics and what's going to happen when they start to really have problems like they've had in Germany with some of the oversupply, where they're essentially selling electricity for negative numbers because they're producing so much when the wind is blowing.
So I think there's a couple of real quick questions, and I know, Ruth, I need to turn it back over to you. To what extent is automation as opposed to energy transition going to be a threat to employment? Yeah, that's definitely something, you know, there's going to be an opportunity for more work to be done, maybe with less manpower or person power. But that's another reason that we're taking a look at how to retrain our students. We want to make sure that the Colorado School of Mines students are the ones that do still get selected, because they have those skills to deal with the automation, to deal with the data analytics, those components. John, can we provide you with some of the backup data? I think if you scroll back up to the top, Jordy Lee in the chat put in a link to some different energy estimates. Really good article. And the other thing is, yeah, I think we absolutely can. We can provide some additional information. And Ruth, can I just say, I'll give it to you and you can figure out how you want to do with it. So
in fact, what might work, Jennifer, if you're okay with this, I know there are more questions. We are at our time. I would be happy to email everybody on the call today with reminding them of your email addresses, which I did put in the chat. But, you know, if you want to share any documents or links, Jennifer, that I can send out to the whole, I'm happy to do that. Sure. You know, tomorrow or Monday. So, well, with that, let's formally close this portion of our program. I did want to make two quick announcements. I've got one, actually Jennifer has one too, but Lunch Bunch, for those of you who are new, this is a monthly thing, right? As you know, Lunch Bunch, we meet every the third Thursday of every month at noon. Next month's program will take place on Thursday, December 10th, and President Paul Johnson is our featured speaker. It is an open Q&A. So if you have questions, concerns, comments that you want to share, it is an open floor. I know he'll have a few updates, but for the most part, it's an open mic sort of a situation. So if you'd like to join us, please visit our website. We'll be posting it. It's posted now, but we'll be sending out in our December alumni e-newsletter a link to it as well. So we welcome you all. Hope you'll join us. Again, December 10th, 12 noon. And Jennifer, you've got one quick note for something happening that you want to do in January. So
absolutely, thank you. So yeah, for those of you who are interested more in some of the research portfolio that we're doing and some of the different projects that we're working on, not just the ones that we talked about today, but even some that are more traditional oil and gas, we're working with the foundation to put together a very similar format like this. That would be an hour and 15, where pretty much all of our research active faculty are going to come in and give you a real quick rundown on some of the projects they're working on right now and some of the opportunities that they see. We just wanted to get some more information out to people, and especially our alumni, because a lot of times you're the ones that bring us research projects. And so for that, just a reminder, you're all here, so you got your emails updated, but please keep your emails updated with the foundation. We're looking to do that probably in January, February of next year. So
awesome. Thanks for the email plug. That is our lifeline to y'all. So if we don't know what it is, we can't connect with you. So anyway, we hope you enjoyed the presentation. Thank you again to Dr. Miskimmons and Dr. Fleckenstein and Jim Crompton. So glad you could join us. And happy Thanksgiving, everybody. You know what? Let's take a break and enjoy, be thankful, be with our families to the extent that we are able. And we're so thankful for all of you ore diggers to keep our machines rolling and keeping the whole network connected. So thank you all, and go ore diggers. See you next month.
Oh, thank you.
Okay, bye-bye now.